So in this case, in question 3, our period is going to be 3 times the regular period. So period equals, and then 3 times 360, 1080 degrees. The amplitude, remember, changing the period doesn't change how high or how low the sine cosine function go, but multiplying it by 2 will. So this tells us our amplitude is going to be 2. So at 0, sine of 0, we have 0 times 2 is still 0, right? At 360, no, let's do one that we want sine of 90. So we want sine of 90, which would be 270. If we plug in 270 degrees into here, that'll give us 270 divided by 3, which is 90. And sine of 90 is 1. And then 1 times 2 is 2. So at 270, which is right here, which is 2, sorry, we get this point here. So at 270, this turns into sine of 90 degrees, which is 1 times 2 is 2. Okay, and then 180. So 3 times, let's see, what can we plug in here to get this to be 180? It would be 540, I think. So, which would be here. And that would, sine of 180 would be 0 times 2 is still 0. And then kind of continuing this pattern, this would be at -1, and then this would be at 0. You can see the amplitude here is 2, and the period is 1080 degrees. Okay, we're going to skip tangent for now. We're going to go to cosine. So we can tell from here that the amplitude will be 3, and that the period will be twice as long. So it'll be 720. All right, since we're dealing with cosine, the cosine of 0 is 1. If we substitute 0 in here, we'll get 0 over 2, which is 0. Cosine of 0 is 1, times 3 is 3. So at 0, when we substitute 0 in, we get an output of 3. Then when we substitute in 180 into here, we get 180 over 2, which is 90. Cosine of 90 is 0, and 0 times 3 is 0. So this will be 0. And then 360, we can put 360 in here, and it'll read as 360 over 2, which is 180. Cosine of 180 is -1, and -1 times 3 is -3. So when we substitute 360, we get -3. And then when we substitute 540, let's say we put 540 in here, this will be 540 over 2, which is 270. And the cosine of 270 is 0. And 0 times 3 is still 0. So by putting in 540, we get 0. And then substituting 720 in here, we get 720 over 2, which is 360. Cosine of 360 is the same as the cosine of 0, which is 1. And then 1 times 3 is 3. So this comes up here. And you could see that's one full cycle because after that, it's going to come back down like this. Like so. And so our cycle is from here to here, and then it just keeps repeating that over and over. Okay, we're going to skip this tangent. So now we're going to use radians. So a little refresher on radians. Okay, 2 pi radians is equivalent to 360 degrees. Everything else comes from this relationship, right? 2 pi radians equals 360 degrees. So if you know this is true, then everything else is related to this. So if 2 pi radians is 360 degrees, then 180 degrees equals pi radians. And 90 degrees equals pi over 2 radians. You could divide 180 by 3 and get 60 degrees. And that's pi over 3 radians. You could divide 180 by 6 and get 30 degrees. And that gives you pi over 6 radians. Okay, and like I said, all of these other ones are just a derivative. They're just, they are just using this, and you can build all of this other stuff. So when we say sine of 3 theta, okay, it says find the amplitude and the period of each function, then graph. So we have y equals sine of 3 theta. Similarly to how we had before, because of this 3 is in front of the theta, that means our radians are cycling through 3 times as fast. So our period is going to be 3 times shorter. Now the full rotation, the standard period is 2 pi radians, but because we're traveling through that 3 times faster, it'll be 1/3 of that size. So it won't be 2 pi radians, it'll be 2 pi over 3 radians. Like so. And the amplitude is not being affected at all, so our amplitude is just 1. So at 0 radians, that's the same as 0 degrees, sine is 0. So that's still 0. Okay, if we put in pi over 2, okay, sine of pi over 2 is 90 degrees. So 3 times that would be 3 pi over 2, or 270 degrees. And the sine of 270 degrees is -1. So this would be down here. And actually, that means that there's a whole kind of rotation that happened here, which we missed. If we put in sine of, let's see, if we put in 30 degrees, it'll give us sine of 90. So 30 degrees is pi over 6. So this is pi over 2. This is pi. This would be like pi over 4. Pi over 6 would be here. So if we put in pi over 6, which is 30 degrees, okay, it's going to read as 90 degrees. It'll read as pi over 2. And sine of 90 is 1. So this will be, it'll be 1 right around here. And then at 60 degrees, it'll be sine of 180. So at pi over 3, it'll be like sine of 180, which will be 0. So at 60 degrees, which is about here, you have this going on. So you've got this idea going on there. And then at 2/3 pi, or 2 pi over 3, so if this is 1/3, this might be 2/3 here. Actually, it might be here, right? Then you plug this into here, and it'll be, it'll count as 2 pi, right? The threes will cancel, and you get the 2 pi, which is the full rotation. So that's going to be back up to 0. So here's our period. Now remember, it'll be able to make 3 periods because it's going 3 times as fast. It'll be able to do that 3 times before it ends up reaching 2 pi. So from here, it's gonna go back up, go back down, go back up, go back down, and then it'll reach there. Let's go ahead and actually calculate some of these. So if we put in sine of, let's see, we're at 2 pi over 3. If we put in sine of pi, it'll read as 3 pi, which is 180 degrees. So this one would be 0, because sine of 3 pi would mean like, it would be like, here's pi, here's 2 pi, here's back to 3 pi, so it's 180. Sine of that would be 0. So we're at 0, which means we're missing an uptick here, which would probably be here. And then there would be like a downtick like this. And then an uptick here, and then a downtick there. Something like that. Okay. We're not going to worry about tangent. We're not worried about secant yet. Let's talk about cosine. Okay, we can see that our amplitude is going to be 2, and that our period is going to be 1/4 of the normal period. So amplitude will be 2. Oh man, I meant to type it this way. And the period will be 1/4 of the normal period. In radians, instead of it being 2 pi, it'll be 1/4 of that. So it'll be 2 pi over 4, which can be reduced to pi over 2. So it'll be pi over 2. This will be a period. So in other words, it will complete 1 full cycle when it reaches pi over 2. And this is cosine. So cosine of 0 is, again, think 0 degrees, right? Cosine is going to be +1. And then multiplied by 2, so the cosine is 2. And we know that what's going to happen is halfway through the rotation, we know that from here to here is a full rotation, from here to here. So we know that this one's going to end up back here. And we know that halfway through, this is going to point in this direction, and it'll be -1. So it'll be -2. And so this will cross here, and it'll cross here. Right? And so you can kind of follow the pattern. This is going to have a point there, a point there, a point there. This will be a point here, a point here, a point here, and it's just going to go like this. Okay, cosecant we're not going to worry about. Cotangent we're not going to worry about. All right. What do you think? Questions or comments? Can you go back to the last one and explain again? Sure. Okay. So where do you want me to start explaining? Here, 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 here. Okay, start with the period. Okay. So a trig function like cosine, okay, is going to have a period. Normally, it will have a period that will be completed when it does one full rotation like that. And that would be like one period. Okay, now, in degrees, we call that 360 degrees. But in radians, that's called 2 pi radians. Okay, a full rotation is called 2 pi. So you could say a regular period would be 2 pi radians. This one is going 4 times the speed of a regular rotation. So instead of 2 pi, which would be normal, right? If you're going 4 times as fast or 4 times the speed, that means the time that it will take is going to be divided by 4, right? The faster you go, the less time it takes. So since we're going faster, we're going to divide by 4. And then these reduce and you get pi over 2 radians, which is the period. Okay. Great. I'm glad that you get it now. Any other questions? Okay, it looks like no. So let me begin. So this was basic graphing, okay? There will be more complicated ones than this, but before we get to the more complicated ones, I want to talk to you about the 6 trigonometric functions visualized. So we know, oh, that's not what I want. We know that when you have an angle here, like you're rotating your angle like this, okay? Oh, that's not what I want. We know that the sine is represented here by this line, and the cosine is represented by this other line. So this is the sine line right here. Assuming, of course, that the radius is 1. So this would be sine. And cosine is represented by this horizontalness here. That's your cosine. Okay, but there's 4 more that we haven't really talked about. I've spoken a little bit about tangent, but not really about the other 3. So tangent, in order to understand tangent, you have to think of a A tangent line. So a tangent is a line that touches the circle in one spot. That's what it means to be a tangent. So if we draw a tangent line here, like this, okay, then this can help us give our tangent measurement. So again, we have our little line here, right? We still know that this is our sine, and then the flat one is our cosine. Our tangent line will be this line here. Here to here. So you can see it's kind of the length of tangent is kind of large there. Let me just double check that that's true. So if we rotate there, I think this is wrong. This is wrong. That's not our tangent line. I was mistaken. Sorry. Our tangent line, you still need to extend this out, but our tangent line is actually this line here. That's right. So what's happening is, as this one here, nope, here we go. As this one is turning, right, as it's turning, this is, let me delete this here. So as it's turning, it's kind of following. You can see that as I follow this up, you kind of get that turning motion, right? So as I just kind of stay on the tangent line like this, you get this turning motion, right? And when you get to here, tangent is actually undefined, right? So at 90 degrees, tangent is undefined. And then when you turn around, assuming I can even grab this little thing. Here we go. And then once you leave here and you start turning again, right? It actually reflects down, and it just keeps rotating like this. It goes from the down up to top like this. So as you're rotating, I want you to imagine a line that is, so I'll start here. Imagine a line that is extending beyond where I'm holding the line here. And then imagine this pink section here kind of extending higher to match where it's connecting. And this pink length will be the tangent length. So you can see from here to here, tangent's getting huge, and then from when we get to there, it is not. I wonder if there's a way that I can visualize this for you guys. I'm sure there is. Let's see. There you go. Look at that. Is there an even better one? Ah. I'm gonna say no. Open image in new tab. So you could see, look at it, you see this purple line here? I know it's kind of, can I zoom in? Right, so look at, as the purple line is rotating, right, you see how there's a part that extends beyond, and it's always connecting back to this tangent line, and you see this red part, that's the tangent line. So it gets really small, and then it gets 0, and then it gets really big, and then it becomes undefined at 90 and at 270. And you see, look at the graph of it, right? As it's rotating, you can see, so watch, it starts at 0, it's getting bigger, 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 and then it's undefined, and then it starts again, and it gets bigger again, and then it's undefined again, and like that. You can see that once it passes 90, it has to use its back end to measure the tangent line. So it doesn't matter which way the line of rotation is turning, the tangent line is always measured to the right-hand side. All right, so we'll leave that there. The bell did just